Hi everyone, in this video I'm going to go through what is a biconditional statement and how we might be able to use that with some of our conditional, converse, contrapositive, all those fun statements. Okay, so we're going to have to first talk about what it is and what it's composed of and how we determine its truth value. So, to expand our collection of logical statements and reasonings is what we're really going to do here. And we're going to be able to build a biconditional statement through the use of this video, okay? As well as break down the biconditional into smaller pieces. So in your notes, you might see a little symbol location. If you don't, please write this. So we've talked about before that P arrow Q means that if P is a true statement, then Q automatically becomes true. So we talked about this normally in the context of it being, if it is raining, then I will use an umbrella. So if the day is raining, right, then I will use an umbrella today. What a biconditional statement is saying that P is true if and only if Q is true. So what it means is that these things have to be true simultaneously. So we want to actually look for this phrase during every single one of these questions, if and only if. A triangle has three sides. The shape is a triangle if and only if it is three-sided. Okay, so we want to think about a statement that is true no matter what. So can I think of any other shape that's three-sided other than a triangle? It's the only one. So we could say a conditional statement is if it's a three-sided shape, then it's a triangle. So this is the conditional statement. Now, if you recall, we had what was called the converse. And this is where I flip the sentence around. So you can read right below it. If a shape is a triangle, so notice how that got switched here, then it has three sides. So you see how these switch? And here's the thing. Can you think of a three-sided shape that is not a triangle? No. So this statement is true. If it's a three-sided shape, then it's a triangle. Can you think of the shape triangle and it not have three sides? So this statement is true. When both the conditional and the converse are true, then is the time we can have what is called a biconditional. Meaning, I can take these two conditional statements and write them together. A triangle a shape with three sides, sorry, I didn't write that the correct way. A shape with three sides if and only if, I forgot my only, if and only if the shape is a triangle. Now, there's a bunch of ways we can write it. That may not be the best way to write it. You can look at my diagram here. A shape is three-sided if and only if it's a triangle. Maybe that's a little bit better. But, you know, the idea is I can't separate a three-sided shape and a triangle. By definition, a triangle and a three-sided shape are always and will always be the same thing. So let's look at another case. So we have a rectangle. If a rectangle has sides that are 3 and 6, then its area is 18. So this is our conditional statement. It's the first sentence we're reading, so we're just going to call that the conditional. So if I think of a rectangle that's 3 by 6, and our area formula is length times width, 3 times 6 would get me an area of 18. So it's impossible for me to have a rectangle that's 3 by 6 and not have the area of 18. That's a true statement. So this works. Now let's look at its converse statement, where I change the order around. If a rectangle has an area of 18. So can we try to construct a rectangle that has 18? So obviously we know 3 by 6 works, but also it could be 2 by 9. it could also be 1 by 18. So this is actually false, right? I can construct an area that a rectangle that has an area of 18, but it does not have 3 by 6. So since this is false, this is biconditional is not true. And let's look at that biconditional real quick. It says a rectangle has sides of 3 and 6 if and only if it has an area of 18. Well, I just proved it wrong. This rectangle has an area of 18. This rectangle has an area of 18. This rectangle has an area of 18. So it's not true that a rectangle has to have the sides of 3 and 6 in order for it to have an area of 18. So that's what these biconditionals are saying. They're basically saying if we have two true facts that cannot be separated from each other, the conditional and its converse, we can write them as one. Back to the triangle. Can I have a three-sided shape that is not a triangle? Can I have a triangle that's not three-sided? This is all impossible. So let's break down. So I have 3 biconditionals, and so we're going to write 2 conditional statements. The first one will be the first conditional, and then the second one will be its converse. Now, it doesn't actually matter which way you write the order of these, because when you do this, you'll get both orders. So I'll just show you how I do this. So I first want to locate the if and only if. You have to locate that because now this is basically P and Q. So remember how we always kept writing if P then Q? Well, once I pick it, now I just have to write each sentence. If a shape is a pentagon, then it has 5 sides. And then again, I just have to flip-flop my P and my Q part. So instead of starting with this, I'm going to actually start here for my conditional, or my converse. If a shape has 5 sides, then it is a pentagon. Okay, let's try one more. An angle is a right angle if and only if it measures 90 degrees. So again, let's actually think, is this true? So if it's a right angle, it has to be 90 degrees? Yep. And if it's a 90-degree angle, is it a right angle? Yep. So we can say, let's call this P, let's call this Q. If an angle is a right angle, then it is 90 degrees. And its converse would be if an angle is 90 degrees, then it's considered, you don't have to write all that in there, but it's considered a right angle. And we kind of want some grammatical correctness here, but, and our final one, if it is a square, if and only if it has 4 sides. So if I start by writing this, if a shape is a square, then it has 4 sides. And then finally, if a shape has 4 sides, then it is a square. Now here's the problem with this last one. Then it is a square. I didn't spell that right. Then it is a square. So here's the problem with this one. Let's look at this very last sentence. If a shape has 4 sides, then it is a square. Is it possible for us to have a 4-sided shape that's not a square? Well, rectangle, parallelogram, trapezoid, a rhombus. So that's 4 shapes. So this is actually false. This first statement is still true. If a shape is a square, then it has 4 sides. Squares have 4 sides. But when we go back and reread the biconditional, if a shape is a square if and only if it has 4 sides. That's not true, because here are 4 examples to prove that statement false. So biconditionals need both conditionals to be true. So if you're not sure if your biconditional is true, this would be the way that you test it. So I just want you to quickly look through all of these. We just talked about them. So just really quickly, all pentagons have 5 sides, and there's no other shape of a 5-sided name. So these are true. So all these biconditionals are true. This one's really specific. If an angle is a right angle, that's true. If an angle measures 90, now you might argue some angles are complementary. If you remember, complementary means angles that add up to 90, but it says an angle. So this one's also true. So everything was true here. And we just talked about this. A shape has 4 sides, but a square does not. So we can just think about it just like we just talked about. And now finally, we're going to talk about how to build the biconditional. And so really, you just have to look at your first 2 sentences and make sure that these are both true. If the date is 7/4, then it's the 4th of July. And if it's the 4th of July, then the date is 7/4. Both of these are true, so we can put them together. The date is 7/4 if and only if it is the 4th of July. And we're not trying to use any sort of European dating system. We're talking about month and day, right? I can't separate the physical date 7/4 and the day 4th of July because they always happen simultaneously. If 2 points lie on the same line, then they are collinear. If points are collinear, then they lie on the same line. Remember, our definition of collinear is any 2 points that are on the same line, and by definition, any 2 points form a collinear. So we can say points are on the same line if and only if they are collinear. So if you kind of realize all I'm really doing is I'm checking to make sure first they're both true. I'm getting rid of the if and then, and I'm just basically putting in if and only if in one of the sentences. And I'm kind of cleaning it up a little bit. I'm not going to be too picky on that, but it's pretty helpful to just, grammatically make sure it sounds right. Okay, so you can try these 2. I'm going to pause this, and I'll come back with my answers so you can see whether you did it correct or not. So pause it now, give it a shot on your own, and then restart the video. Okay, so I've returned with my answers. A number is odd if and only if n squared is also odd. So again, I really just kind of took this initial sentence, crossed out the if, crossed out the n, and just added if and only if. If you actually read the first sentence as is, I think that's the same thing. So that's, there's not a lot of extra work we have to do. We're just trying to clean up a sentence here. This one was a little bit harder. A polygon is a shape with many sides. So this is a fact. And so I broke it into a shape is a polygon. So I took the first part. If and only if it has many sides. That's all we have to do. Okay, so there is a little quizzes that you should be able to access in Schoology. So do me a favor and complete this little quizzes practice that you'll be able to access in Schoology. And then you should have a little bit of practice on all of these statements. So hope that was helpful. Feel free to rewatch it if you need it. See you in the next one.